Alright, I am back again for Odinmade Hero. Today we're going to kick off day 57 of me learning from Casey Muratori over here about how to make a game from scratch. But we're going to do it in Odin while he does it in C and C++. So I'm translating that C code over to Odin and just kind of teasing apart the nuance as I do it. Why won't this tab stop reloading? Come on, YouTube, you can do it. There you go. So yesterday we focused on embedding game entities from our game state into the game world, and we also spent some time kind of converting this notion of having one big tile map in the world to just having a game world with a bunch of different world chunks in it. But before we start today's code on spatially partitioning entities, I wanted to go over something that I was talking about at the beginning of the stream yesterday. And I was kind of being wishy-washy about it, and that is, using these built-in constants from Odin's mem package to represent the different, sized bytes, terabytes, gigabytes, megabytes, kilobytes, so on and so forth. And what I was hoping to do was something like this, where we could still have these procedures that we wrote with Casey way back when, but have them take, just an untyped integer, essentially, and then spit back out whatever we needed it to by casting the result. So in here, we would have just done this, right? We get our value, and maybe this would actually work if it was, if we could specify the type, like untyped int or something like that. I'm not sure. But basically the way that I was doing it, or the way that I was trying to do it, was inappropriate. For whatever reason, this is just something that Odin doesn't like us to do, because if I do it, that's right, I have to uncomment this import out, and now I should be able to show you that when I do things this way, we can't actually write the game DLL. And I suspect it's because these constants are untyped, right? Or something to that effect. So using parametric polymorphism to, take an untyped integer, there's just something about Odin's type system that doesn't like this, and probably rightfully so. This was probably just a dumb idea that I had. I just wanted to be able to nicely say, I want X number of megabytes or gigabytes or whatever. But the simpler thing to do, and what I probably should have just done from the get-go so I wouldn't have wasted time figuring out that that was a bad idea, is just this, right? Where we just multiply that constant by whatever coefficient it is that we want to represent the total number, right? So I want 256 megabytes for my permanent storage size. I want 1 gigabyte for my transient storage. And that just seems to be the way to go. I guess as far as this goes, I was hoping to do this, right, where we pass in that number and then multiply it, basically just wrapping that operation and making it a bit neater, I suppose. But maybe there's a way to do that without using these, using parametric polymorphism. That was probably just the wrong thing. I also talked about using like any int, and then it was like, okay, but I still have to cast out, like what we could do, right? I'll just use the megabytes example since we actually want to use that one. If it was like this, and we had our value, and it's just going to be an int, but we can take anything, so it could be untyped, which by default I suppose would resolve to an int, and then this would work, and then I could go back here, I think, and just do it exactly like this. But that's just a whole lot of ceremony for nothing, and this actually needs to be like that. So this probably actually works, but it just seems pointless. Yeah, that does work. It just seems pointless to have these procedure calls when you know, if we do it this way, we're not hiding anything about what's going on, and we don't have to do any casting. It's like a very trivial example, but it's a good demonstration of, like, you know, to me, when do I feel like something I'm doing is just completely unnecessary or not? And part of this is moving it over from Casey's C and C++ code and just trying to figure out, like, what's the best way to think about this in Odin. And I think it's probably just this, right? Maybe that's wrong, but for now, I think we can just go ahead and get rid of all of this, because it's just code sitting around doing nothing, and we can just use those constants to get whatever number of storage size. And I don't know how much more often something like that's going to come up. We weren't using any of those procedures anywhere else, but I suspect that, you know, Casey will need to refer to them again at some point, at which point we'll just use the constants, right? So nothing too special going on there. So with that being said, let's go ahead and jump into day 57.
Hello, everyone, and welcome to Handmade Hero, the show where we code complete games from scratch, live on Twitch, using nothing but our very own handwritten code. No engine, no libraries for us. It is our code or nothing here on Handmade Hero, and we are right in the middle of doing sort of our structuring our sort of code into the, I guess I want to say, one of the most important parts for later on in development, which is kind of how we process, think about, and store entities in the world, where they are spatially, how they get updated, that sort of thing, how they are tracked, how they interact with each other. That's what we're working on right now, and we're partway through it, and I want to get right back to it because we do have a lot of work to do. So I'll briefly just say that if you are following along, if you pre-ordered the game and you're following along with the source code at home, you should have received a link in your email. That link allows you to download a zip file. Inside that zip file is one zip for every day. Since we're on day 57 right now, you want to unzip day 56's source code. And if you do that, you'll be exactly where I am right now, so you'll be able to follow along with everything I do if you want to sort of see how to do it yourself. Okay, so let's take a look. If I remember correctly, yesterday we had just sort of finished pulling things out into handmade world.h and .cpp, and we were starting to get our entity update scheme in place and figure out exactly how we wanted to move things in and out of our active set and so on. And I had turned on smooth scrolling for a minute just so we could kind of see what happens when we scroll around. And you'll also notice that we don't sort our entities now, so entities like the wall entities and stuff will occlude the player improperly because, like I said, we haven't done any work on rendering yet, so we're just entirely doing this in whatever order the entities happen to be in. So what I'd like to do now is I'd like to sort of go through and continue to refine that code the way that we had it. And what I'd like to do there is I'd like to start making a world that's very, very large. I'd like to go ahead and start creating a world that's quite sizable so that we can start to see exactly what the world, how our code will behave under a heavier stress load. And we can start to do some things like verify that we are, in fact, moving things in and out of the active set, and we're not just processing everything through the high entities and so on. So I'd like to sort of get into sort of go in that direction. And there's one really big thing that I'm not sure exactly how we want to do yet that I'll also point out while we're doing that, which is kind of something that I think will probably come into play later. I don't know exactly when we'll start to play with that, but let's go ahead and look at that now. So what I'd like to do is I'd first like to say, well, let's go ahead and start. Since we know that we don't apparently at the moment have any real issues, even though we're not doing anything particularly intelligent with our spatial sorting. Let's go ahead and start sort of creating a lot more of our rooms, right? Because we had a thing that would create screens, and we could basically pick a number of rooms to create, and it would go ahead and create as many as we told it to. So I'd be interested to see what happens if we just crank that number up, right? And I believe we are no longer creating all of our dummy entities here, so we should have plenty of room to create a fairly large number. So if we were to say create something like 2,000 rooms now instead of the number that we had been creating, I'd like to see first of all what happens there, just to make sure that actually happens properly. I realize I don't have any more a key to like speed this fellow up, which does seem like something that I probably don't want to do if I'm walking through here. It also is the kind of thing where I wonder if I would also want to be able to zoom in and zoom out on the map, or show some kind of, at some point we're going to have some way of showing the map a little clearer for our own debugging purposes. Unfortunately, since we don't have a renderer yet, our options are a little bit limited in terms of what we do and don't do, that sort of thing. But it does look like we don't really have any particular problems here. What I want to do, though, is I want to walk a little bit further away. I just want to take a little bit of sample here again, since we don't have any debugging support or anything in particular right now. I'm just going to do this by straight manual inspection. What I want to do is I want to set a breakpoint just when I'm about to do some rendering there, and I want to just take a quick look at the game state to see what exactly is going on in the game state, how many high entities there are, how many low entities there are. So there's 159 high entities in that set right now, and what I want to do is just I want to make sure that as we traverse the world, that number stays fairly consistent, right? Because the idea is that things should be moving into and out of. We know when things are moving into. We know that things are moving in properly because, as you can see, it's still drawing all of these things, so they're getting pulled into the set. But what I want to make sure is that they're also leaving the set properly. And like I said, in the future, when we have a little bit more in the way of a renderer and debugging services, we'll just print those numbers out. We'll just overlay them right on our sort of our console, basically our heads-up displays will show us this information. But for now, I just want to make a quick spot check just to make sure that it's not wildly incorrect. So that is still going up. That's 219 now, and I'd like to make sure that it's not monotonically increasing. Like I want to make sure that that's what should have happened, that we're just overlapping more things at the moment, and that it's not continuously going up. And so I'm going to double check that again, because if it just keeps going up and up and up, then that means that there's something wrong with our eviction scheme, that our eviction scheme is not actually removing things from the low entity list like it's supposed to. Now, again, there's also things we haven't really checked for, like we don't know about whether we're getting duplicate things moved in. There's a number of things that we probably will want to check for eventually, but for right now, this is just sort of doing a little minor due diligence just to make sure that we're not really messed up. So let's see. So things look a little jerkier now. So I'm going to go ahead and say I think, unless that's just, I mean, one of the things is our frame rate is not particularly great at the moment anyway, and we're running in debug, not release mode, but even so, I just want to make sure that that's not the case. So there we go, we're back down to 168. So I think we're okay. Looks like our basic scheme of eviction is working fine. And again, all this is trying to do is just make sure that the entities that we actually care about, the ones that are around the player at any given time, are actually of a limited, finite, bounded number that we know we can handle. So what we'd like to do is say, we're going to pick some number of entities that's around an immediate vicinity of the player, and we're just going to always keep it to that number. And so 200, 300, that seems reasonable. I think we'll be able to write our code fine. They'll be able to handle that number of entities, so we should be good to go. So I think that's all working reasonably well now. It's all good. So the next question then that I have is, we started to use this, we started to create this spatial partition. I wanted to be able to make a spatial partition, and the reason that I wanted to make this spatial partition was because I didn't want our code to constantly loop over every single entity in the system every time the camera moved, because I was afraid that would incur so much overhead that we would start to pay for it. Now, we did a test yesterday and determined that actually the number of entities we could just cold loop over and not have to worry about too much was actually pretty high. We got up to about 1 million, and we were still able to do it okay. At 5 million, it clearly broke down. And again, that's just doing the checking to see whether things need to be pulled into the active set. Now, it's a little misleading because we don't actually know how much work we're going to have to do in a number of these situations, but that does tell me that really we might be able to let this one slide. I'm not sure one way or the other. But what I would like to do is say, well, for the sake of actually showing how to do this cleanly and well, I think I want to still make the spatial partition. On the one hand, not that useful, but on the other hand, it will also allow us to be kind of crazy scalar if we want to, where we can have millions of entities and not have to worry about it, because we will be able to sort of break through that barrier trivially, because we won't be paying cost for all those extra entities every frame. So what I was doing here was we were sort of talking about, well, I want to start storing the entities. I want to store which entities are in which locations. So basically, our world would be broken up into the same chunks that we were using for the tile map, but since we've kind of jettisoned the tile map, we're just going with straight entities as the way that we store the world for now. I want to basically take those same chunks and make them basically entity chunks. So each chunk in the world is now, instead of being about a certain number of tiles, it's about storing which entities overlap that chunk. And then when we want to bring things into the high set, what we can do is we can go ahead and grab those right off of there. Now, the other thing that I point out is I suspect that looping over the million entities thing was also a little deceptive in one sense, which is that as we get a little further down the road, we may want to have a lot of entities that are doing things, moving around out in the world, that are sort of autonomous AIs in the world doing stuff that's far away from the player and can't afford to be simulated in that high resolution, because all of the stuff outside of the player's area is not being simulated at high resolution. And I thought of this last night that I wish I had mentioned on the stream. That looping over the million guys was just for one operation we need to do, which was pulling things into the active set. But what's important to remember is we would have had to do that loop over 1 million for any operation that was spatial that worked on the low entities. And so really, that would have gotten out of hand quickly, because let's say we had 100 entities that were autonomous and working throughout the world, just moving around. Each one of those 100 would need to make queries to see what was around it and where it could be moving and stuff like this. Those would have incurred that same million-time loop. And so really, when I thought about it after, I was like, oh, duh. Like, even if we only had 100,000 entities, we probably would run into this problem, because it would shoot up to 5 million queries very quickly, because if you don't have a spatial partition, you have no way of cutting them down. So again, just to be really clear about how this works, we essentially are going to have, oops, that's not what I want to do. How do I get my color back? Let's see here. I don't know why this constantly switches away it switches to the eyedropper tool for no reason. That's my only, so like you alt-tab, I guess it's because the alt key, it's because the alt key does it. They don't know how to write keyboard handling code on Windows, is basically what that boils down to. So again, what this is for is we have a giant world, and we're at any given time looking at a tiny little piece of it. And we've got all kinds of entities out here, right? And in the future, any operation that we want to do, so let's say one of these entities here wants to know, if there's anyone around him who's hostile to him, right? And because he might attack them or he might run away from them. What we want to be able to do is restrict that query so that we only have to consider a low number of entities that might actually be near him. Because if we crank up that number again to like 100,000, right, then every single query, if there were 100,000 total entities in the world, every single query that he does will touch all 100,000 entities. So you end up with what is essentially an ON squared. I know we haven't talked about order notation much yet, but basically if you think about how that works, every entity that in the world that might want to do one of those queries, if we didn't have a spatial partition, something of getting the numbers down, it would have to go check every other entity. So every entity would be checking every other entity every time it wants to go. And so if you think about how many entities there are, if there are n entities, then if every entity has to, every time it wants to update, check all the other entities, that is an n squared, that scales relative to n squared, right? Because every n, each individual entity does an n number of checks, right? And that, as you know, is a curve that looks like this, which is totally untenable, right? You want all of your stuff to scale very flatly so that you can crank those numbers out. This is not something that scales, and that's something we'll talk about a little more later, orientation. We won't talk about too much now. But point being, so the whole point of the spatial query is to get it down so that it's nice and cheap to do those queries, to levelize this number so that instead of 100,000 guys each asking questions about another 100,000 guys, which results in that 100,000 squared, which is a disastrous number, well over the 1 million that we found we could do successfully, right? We want to get it down so it's just, okay, the people who need to check, they only check, 100 entities around them, right? Just in their immediate vicinity. Or something that's much more levelized in an effort to keep it down to this kind of number, the total number of iterations we need to do through a spatial check. So that's what we're doing here. And I'd like to go ahead and finish up what we were doing, because we started most of it, but we just didn't actually end up getting to sort of implement the code. We sort of structured it and then left it. So what I want to do is much like we used to be doing, where we would sort of say, I want to insert this particular entity into the world. What I want to set this particular tile map value. What I want to do now is just be able to say, I want to insert this entity. So what I'm going to do is have a function that's called insert entity into world, or something like this.
Hold on, I do not see something that I feel like I should be seeing. Well, maybe I never implemented this. He has the centered tile point function, but all that does is create a world position and return it. So maybe I just decided I didn't want to do that, and I just had it declared inline wherever he's calling that. So, but I know we have this. Yeah, subtract. Okay, just get caught up really quick here. Insert entity into world. Seems pretty verbose. So we're going to change that. I feel like just insert entity, maybe.
And what that's going to do is that is going to put this entity into where it should be in the world entity blocks where it is. And to be honest with you, I think I'm actually going to jump the gun a little bit here and say that what it's really going to be is change entity chunk, or change entity location, right? Where what we basically do is we say, we're going to tell you an entity number, right? We have a low entity index, one of our entity numbers. What we want to do is say this entity is going to move from where it was to where it is now, okay? And so what it's going to do is it's going to take one of these world positions, right? It's going to say this is the old position, and then it's going to say this is the new position. I'll just do new p and old p. And what we'll do for now is we'll allow world position old p, we'll allow old p to be 0 potentially, so that if this entity was not, and when I say 0, I mean the pointer will literally be 0. It will not point to a valid world position. So what this will do in that case is it will actually allow us to sort of say this is a new insertion. This entity didn't exist anywhere in the world yet. Please put it in where the new p is. So the first thing I would do is I'd say if old p, right, in that case, we want to see whether the old p, is not equal to the new p. Basically, we want to be able to do a check. And I think we have, well, we had are on same tile, so we want to do something like saying, if these are in same chunk, right? So I want to basically be able to say if the position that this entity was in and the position that he needs to be in are the same, then we don't have to do anything, because wherever he was inserted in the spatial partition, in our whichever world entity block he resided in, is correct for him, basically, right? But what I want to do in the other case, so this is leave entity where it is. In the other case where it's different, or in the case where old p doesn't actually exist at all, in fact, I guess I could do this slightly a little bit differently. I might say if old p and are in the same chunk, right? Then what I'm going to do is leave it where it is. But in any other case, what I'm going to do is say, all right, if there is an old p, then the first thing I need to do is pull this entity out of its old location, right? So that'll be what this does here. This will say pull the entity out of its current entity block. And then I will go ahead and insert the entity into its new entity block. I should say its old entity block. So this will basically be a search through the spatial partition to find out where the entity actually is now. We'll yank it. Then what we'll do is we'll say, OK, let's take a look at where the entity needs to go, and we'll go stick him onto the end of the list there. All right. So we know that we can query, right? We can do a get world chunk here.
Slow down, Casey. OK. We'll insert the entity into its new entity block. So this is kind of answering a question that was immediately apparent to me that it needed to be asked yesterday, which is like, what do we do? It answers part of the question of what do we do when an entity, needs to move into a different chunk. And turns out, we were already going that way. I just had to be patient. I didn't remember this particular detail for whatever reason. I think because when I was doing this project in Zig, I just kind of zoomed through as fast as I could to get to the renderer stuff, which means that I didn't appreciate writing the entity and world stuff as much as I should have, which is, why this is good that I'm doing this now. So just like the code says, right? If we don't have an old position and, well, looks like he's gonna dereference these, first of all. I see, to make sure that old P is not nil before dereferencing it. Okay. And then if it turns out that we do have an old position and a new position, but they're all in the same chunk, then that makes sense. Otherwise, if we do have an old position, then, and therefore we do have one, but is not in the same chunk as the new one, right? Go ahead and pull that out of there. Otherwise, we would just be adding the entity into its new entity block, but it doesn't apply, right, if it wasn't in a chunk to begin with. Okay, I think I can follow that logic. That makes perfect sense to me.
Can query, right? We can do a get world chunk here. So we know we can grab the world chunk by its chunk X, chunk Y, and chunk Z. Yeah. So we'll go ahead and do that. We'll get that back. And this is going to be the new chunk X, the new chunk Y, and the new chunk Z. Now, what's interesting about this is what we want to do as well, like a separate thing that we'd like to do now, right? Is we don't really care about tile indices anymore, which is what we were tracking before. We used to be tracking tile indices and then offsets, right? But we don't really have any need for that anymore because now we just have chunks, right? We don't have any real need to conceptualize where tiles are. That can be strictly an artifact of the world building. The world building can consider things in tiles if it wants to, but once it comes to actually storing the world, we don't care. So really what we want to do now is we want to call these probably the chunk X, chunk Y, and chunk Z. So that what we can do is say that the world position is now based entirely on those. So we now no longer have any restrictions. We don't have to even do the chunk shift, chunk mask, chunk dim stuff anymore. All we would need is a single thing, which is that whatever the chunk side in meters is all it is, right? So this is actually could just go away entirely. And what we can say is this is going to be chunk side meters. And we don't care what the tile side in meters is because the tile side in meters really is just something that the world building will do. So you know what, though I will perhaps still store it here just so we know. And the chunk side in meters will just be some amount above that, right?
Interesting. So I do like this because when I look at these values and I try to remember how they relate to each other, there's some shifting going on to calculate that stuff after you set the, I think it's the chunk dim, maybe. And like I should really be better about that. I should have like a better intuition around shifting bits around. And I just don't. But the fact that we're getting rid of it tells me, okay, I don't have to be as concerned about that. It's still something that I should understand because especially like if we go back into the, that load bitmap code, this was harder to understand where I was going wrong, specifically because stuff like this, like I look at that and I'm like, what the hell is this? That's a lot of stuff that is a little bit just above my head. Like I've got a better understanding now than I did right before I ever touched Odin or Zig for that matter, but it's still like just out of reach. I can feel, I can understand what is going on conceptually, but when I look at it, I can't immediately say to what extent, and part of that is because some of that stuff is dynamic, right? Like the let me go back there. The red, green, alpha, blue scans and masks, like they're dynamic based on where they're embedded in the header, right? What, and then there's other confusing stuff going on here. Like we have this kind of mishmash of OS calls and BMP calls for reasons that I don't want to dwell on at the moment, but that's still a thing I've just been thinking about in the back of my head. Like if I want to go and actually use my own assets, I probably wouldn't want to do things that way because that's just adding more possible issues that I could get stuck on, right? I'd probably want to use something that's a little more well-established or a format that's more appropriate. I don't know if BMPs, it sounds like there are new file formats that I should be. And then also, like, it depends on what you're actually doing, right? Like, if it's a mesh, there's a whole other like range of file formats that aren't just like specific to like, you know, BMP, JPEG, PNG, whatever, all these different image formats. Anyway, kind of neither here nor there, but just some things that I keep thinking about from time to time that I want to make sure that I come back to, and I have a good enough understanding of the problem space to be able to move forward on the right foot rather than start going down a bad path. That's the thing that I want to avoid. And because if you have the wrong conceptual understanding of what it is you need to do, then you might spend a lot of time writing a pile of crap, basically. So now everything, yeah, that's right. We were just changing that abs tile stuff to be chunk X, Y, and Z, and then all of this was going away. And then, like Casey said, we're going to store the tile side in meters and the chunk side in meters as well.
So there you go. Okay. So we'll store the chunk X, Y, and Z directly in there, and then offsets will be from the chunk center. And that is how we will store things, as these nice little chunks. So if we go ahead and do that, then what we should be able to say is that we can just...
I feel like he just changed something and I didn't even... Oh no, he does this thing where I think he's making a code change in a split second while I'm looking away, but he's actually just jumping up and down like this. He's going... But that just kind of sounds like, right, like he's typing some stuff out, but he's actually just kind of hopping around the code to show something that he's talking about, to illustrate where it is in the code that he's whatever he's talking about is related. Anyway.
Okay. So we'll store the chunk X, Y, and Z directly in there, and then offsets will be from the chunk center. And
you did say something. Okay. Yeah, he wrote in, or he did type something. He wrote in, where was that? He was hopping around, but he wrote, all he did was update a comment. Or was that? Do I even have that comment? Where is this offset? It's up here. Apparently, I never even had this. I think maybe I did used to have this comment, and I got rid of it. But we want to make sure we have that, so that we remember that this is from the chunk center. Okay.
That is how we will store things, as these nice little chunks. So if we go ahead and do that, then what we should be able to say is that we can just directly access off of this world position. We can directly access what those chunk coordinates will be and pull the chunk out straight from there. Okay, so that'll pull that out directly. And then we would pass a memory arena here if we needed to store stuff. And in this case, we actually do. So we're going to want to pass a memory arena like so that we always guarantee that we have the ability to allocate more space if we were trying to store something that that requires, say, allocating a new what's the word for it? Entity block, right? Okay.
I just noticed I'm on mute. Great. Jeez. I'm just going to have to stop muting myself. I don't even understand when I last muted myself. So all I was saying just there for probably a solid 5 minutes before I realized what was going on is that this issue with this call right here, right, this is why I added this to do, right, is that I don't know if I should pass in an allocator here, and I don't know if that is something that I should do, right? I want to try and do things with an Odin sensibility to them, and that's why I diverge from that the way that Casey is doing it with that custom arena that he wrote, and I'm using the context allocator that I set way back when we did that code. I want to be able to say, I want to know whether I should say that there's an allocator being passed in here, a pointer to one. Like, is there, and maybe that's the way to write this comment actually. Should we actually pass in a pointer to an allocator here? That seems like the wrong idea, but I never made time to actually look into whether that is something that I should do. And I really should. But basically, you know, wherever, I guess the problem with it is that whoever's calling this, and we're only calling it in one other place, I think. No, we're not calling it anywhere else. Well, wherever else it's being called, it would be called get tile chunk. Yeah, so we were calling it over here and over here. And we would say true if we wanted to allocate and not pass in anything if we didn't. But over here, we would basically have to do something like, you know, create a new allocator and do it by copying the current context allocator. But that just seems wrong. But at this point, then we'd be able to pass in a reference to it, maybe. But I don't know if doing this means that both this thing we're declaring here and this are using the same arena underneath the hood, or if it's making a copy of it. Like, what weirdness am I inviting into the code by doing that? So that all I was saying there, before I realized I was muted again, I just need to stop doing it. No more muting until I have like a better way of being able to tell. I need some light that's like flashing in my eye to tell me. And certain microphones actually do that. There's that, what is it, like the Blue Yeti or something? But the way I have this whole setup configured right now, I have no such thing. Maybe another way to do it, might be able to do on my interface. Anyways, that's on me. I need to fix that and stop doing that. So anyways, I'm just gonna leave this in here and take another look at that, because this just, even though doing this would be, what did I do here? Yeah. Even though doing this seems kind of strange, like it might be kind of strange to do, this doesn't really feel good either, where we just have a true or false flag. I never liked doing stuff like that, which I think is what I said back when that was originally written. But anyway, carrying on.
So here we go. We're going to get this world chunk. So this is the chunk that we have. And then what we need to do is say, for this world chunk, we want to go ahead and push this entity onto onto its set. So you remember, we've got this here, world entity block. World entity block stores some number of entities. It stores them in blocks of 16. So what we're going to do is say, if this chunk could have fit a new one, then we push it on. So we basically say, you know, if chunk entity count, we'll check here. If the chunk entity count is already equal to...
Great. Now it is dark. I forgot to plug in my light panel over here. Sorry, 1 second. Where did this cable go? Never ends. All the things you have to deal with. Come on now. You can do it. Hey. We have light again. Okay. So over here, he adds in this check to see if that chunk is at max capacity, right? And then if it is, we'll make a new one, it seems.
16, or I should say the array count, so however many it can store of those low entity indices. right? If it's equal to that, we're going to have to make more room for it, and then...
Well, what he just did doesn't seem right either. I'm guessing he meant to... Huh. What is on this thing? Oh, yeah. That is an array. It's just kind of weird, right? I want it to be plural because it's an array. I want this to say indexes, or probably more correctly, it should say low entity indices. Because when he did that, and that doesn't even seem right. I feel like that should be, you should be checking the first block, low entity indices like that. But he just calls it like this. Right, and that's not gonna work. So I think this is basically what we meant to do. What is this complaining about? Has no field entity count. Well, the first block does, right? Is that right? Yeah.
And afterwards, we can go ahead and push it on. We're out of room. Get a new block, right? So what we want to do here is we want to grab a new world entity block, and the way that we're going to do that is actually not quite what we will really... We've got one more thing I'll show you, and it'll literally be in about 10 minutes. We'll go back and add something to this, but I'm going to go through it directly first so you can kind of see why we're doing it this way. So we're out of room. We need to get a new block because there's no room left in that block, or we may find that sorry, I'm looking at this wrong. So it's actually our block here. So what I need to do first is actually grab that block out. So world entity block, block equals the address of chunk first block, right?
Okay, that makes more sense. So we get the block out of this thing, and that's going to be the address, like you said. And that looks better.
Okay, so if that block is full, we need to get a new block. So
you also never changed anything. Like, you never went and added R in same chunk. I'm guessing it's because it's supposed to be R in same. It's this proc needs to be updated from R on same tile. Let me make sure we're not using that in a bunch of other places. It doesn't look like it. It looks like we were not using this anywhere else. And I think I saw him update that too, so that all of this would be off of a chunk instead of abs tile, and then this could just be changed to that. This is all gonna have to be updated too, and looks like we're good.
What we're gonna do there is say, oh, well, I'm really glad we did this. So if you remember, I said something very specific. I said, back before we did this, I said, world chunk hash should probably switch to pointers if tile entity block continue to be stored unmasked directly in the tile chunk, which meant if this was not a pointer, then this should become a pointer. And we've received the answer to the question. So, can you guys see what it is? The answer to the question is no. This should stay how it is, and this should become a pointer. The reason I know that is because as world entity blocks fill up, what I don't really want to have to do is I don't want to have to do the block copy when they fill up. Now, I guess what I should say is I guess we don't really know the answer quite yet, because it may be that doing that block copy is actually not that expensive because we only do it when we fill them up. I talked myself out of it. See what I did? I talked myself out of it. The thing that I'm considering here, just to be 100% explicit, is when this gets filled up, we need to make a new world entity block. In order to avoid copying the block wholesale, what we would need to do is we would need to have this be a pointer so that we could then create a new one and point to the new one and then have the new one's next pointer point to the old block. So we just basically making a daisy chain of these things as we go. And so that's what I was assuming I should do, because I was like, well, I don't want to have to do that whole block copy. But then I realized that block copy is not that expensive. We only do it every 16 insertions, and it's really only done at world building time, probably. It's probably not something that happens all that often in regular play through the game necessarily. So it may actually be the case that since querying is a much more frequent thing than reinsertion is, that actually the decision should be the other way around. We should leave those first blocks in there. Yeah, so it's hard to say. It's hard to say. So maybe I will leave it this way. Maybe I will leave it this way. So what I'm going to do is I'm going to leave it this way for now, and we'll just have to, say basically to do profile this and determine if a pointer would be better here, right? So when we get a new block, really easy. Obviously, we're going to do a push on our arena at this point because we have to add some more space. So we have to do our push struct. There we go. So we got to do a push struct, and what we want to do on our push struct is push a new world entity block, right? So that's going to take that arena. That's just going to use up some more of that space that we've got. And when we do that push, what we're going to do is we're going to get that world entity block back. So this is going to be our new block. And then what we'll do is we'll just say, well, the new block that we made is actually, I mean, really, we could call this the old block in some sense, because what we're going to do is we're immediately going to take it and we're just going to block copy whatever was in the block that we had. We're going to slap that right on top of it, right? And then what we're going to do after we're done with that is we're going to go ahead and say, all right, now that block that we've got is now considered empty. So we copy the old block, and the new block is going to be considered empty. So we're going to set its old pointer to be equal to the, its next pointer to be equal to the old block, so that you can still get to it. And then we're going to say that its residency, right, the entity count, is now 0. So there's nothing in it now. So we essentially just made a copy of the block, pointed to it by the next pointer so we can still get there if we want to walk it, and then we just vaporized the one that we had so that now it can accept a new one again. So then what I'm going to do is go ahead and assert that if we got here, that we definitely do have room to store it now, because we know that we should have made room for it. And then we're going to say that block's low entity index at the entity count is going to be equal to the one we're trying to store. So this reinserts it, right? So this does our insertion. Again, it's a little hard to concentrate on these things while I'm talking, so I may have made a mistake in there somewhere, but that's basically the idea. We'll step through it to check.
I feel like I can't hold anything against him because I'm just listening to him. And granted, I am also coding, but I'm just listening to him, and I can barely keep up with what he's saying. So, yeah, he's still on the fence about whether he wants that first block on each world chunk to be a pointer, and that's where that new to-do came from. And then over here, still need to write this in. So in the low entity indices, we take the current entity count to be the index that we want to assign this low entity index to in there. And so this happens regardless of whether or not we've made a new one. And I'll just kind of step through this and make sure I'm understanding what's going on here. So we get out that first block from the chunk. We ask ourselves, hey, do we have a full block already? And if we do, we go ahead and make that new one. And then this is the part that he said it, and I didn't immediately connect that to the code we were writing, but let's just see here if I can make sense of that. So we have the old block, a pointer to it. We dereference it and say that all its values are at the current one. Okay, that makes sense. And then the current one, we are saying its next pointer is now the old one. And then the current one we have is just initialized to 0. And I guess that means that you don't have to zero out the old one, because it's just going to get, you don't have to zero out the values that are still in there, right? Because they're going to have the same list of low entity indices, but they'll be overwritten, right? Starting with the first one here, if that just happened. I think that's sane. I think I can understand what's going on there. So, yeah. Why not?
And so now what we need to do is we need to do something that will pull it out of a block, right? We need to be able to remove it from a block. So we've got our old P here, right? And our old P, we need to grab that chunk out, right? And we need to go ahead and see, excuse me, we don't need to...
It's like tempting to think about, okay, well, if we pull it out of its old block, how do we do that? And then try and do that ahead of Casey, but I don't know if I want to trip over myself to try and do that, but we'll just go ahead and do this and get out the old chunk. And I still need to pass in the world. And we're not going to allocate anything because it should just be in there, right?
Pass the arena here because in theory we should always get a chunk, because otherwise whoever called us.
Okay, that was very serendipitous timing because he just immediately confirmed what I just said. So this should always bring back a chunk, right? Because if there's an old position, that means there always had to be an entity at that position. And does that mean we're going to have to search that old chunk and then essentially strike out the value from its low entity indices? I guess I don't know how we would do that. Or it's not immediately obvious to me what the best way to do that would be. I'm sure Casey will just drum it up for us here in a couple of seconds. So inside of the first block, well, then we need to search each of the blocks, right? Because we know it's in this chunk, but we don't know which block it's in. So we would need to start here and then while, let me think about this. Yeah, for as long as block does not equal nil, right? Because we're going to walk to the end of all those blocks in that chunk. We're going to search for the entity here. And if we don't find it in this block, we just say that the block equals its next pointer. And this needs to be an address again. Something like that, right? This part, I'm not sure about how that's going to work. But if we find the entity, right, then we would break. It'll be something like that, I think. We'll see if I'm right.
Is totally wrong, right? Basically, if somebody called us with a bogus position, we want to assert that immediately, like something went very wrong there. Since this is not necessarily a high-speed function, you know, it's not going to be called billions of times a frame or anything. I'll just go ahead and do the extra if here, just in case for some reason we do ship with a bug or that happens. Instead of crashing here, we'll just go ahead and handle it. We'll say, all right, we didn't find the entity in there. We'll just assume that everything will keep on running, and maybe the game will still play fine anyway, because we're about to insert this guy into the spatial partition in a new location anyway. So I go ahead and I check to see, but again, yes, I put the assertion in there because I also want to know if that's happening in a debug build for sure, because it should never be happening, and it's strictly a defensive maneuver to sort of prevent a catastrophic situation that I would be checking for that. So when we get the chunk back, now what we need to do is basically run over the blocks, and we need to find this entity so that we can pull him out, right? And this is pretty slow, so we're going to have to think about if this is something that we want to be able to speed up in the future. We're going to have to profile and see. It depends on how often we need to change, because remember, we only need to do this when the entity actually moves from one block to another. So thankfully, it's not something that happens every frame for every entity. It's something that happens occasionally for entities that move outside of the block that they were in before. So we may not have to accelerate too much, or we may have to. We will see what happens. Okay, so here we are in the chunk code, and what we need to do is now run over the list of these world entity blocks that we have until we find it, and then when we find it, we'll yank it. So we've got our world entity block. That's going to be that first block, right? So we're going to start there. We're going to continue for as long as the block is a valid pointer. And assuming that we didn't find it, we're going to go ahead and move on to the next one along in the daisy chain, right? This is a singly linked list for those of you who like terminology, right? We essentially have what is sometimes called a sentinel, but that term can mean different things to different people. So what I simply will say is we always have one link in the list always there. And then what we're doing is we have pointers that allow us to chain as many additional ones on as we want. But the list can never be effectively entirely empty because there's always at least one that's hard code stored right in the world chunk there.
So the good news is I was right, and this is essentially what we're going to do. It's just I'm still a little wobbly on what syntax I want to use. I think we're basically doing exactly this I think it's when we get the chunk itself. Is that right? No, actually, we're doing it this way. So maybe I'll just do it that way and try and be consistent about the way I'm doing these things. So we would say that this is going to be this. Whoops. And then for as long as block does not equal nil, that doesn't change, but instead of doing this at the end of the loop, we do it here.
So as we move through this, what we want to do is we want to scan to see if that entity is in this block, right? And what we can do there, actually, in the future too, is we could use wide tests. We could use like SIMD style test to test 4 entities at a time or something like that as well. So in the future, we could speed this up even mechanically without making the algorithm any smarter. We could actually speed up just the implementation of it as well. But for now, we don't have to worry about that because again, we're not really at a performance place where we have to think too deeply about minutia like that. So when I come in here, what I then want to do is just scan through inside each individual block and see which one of the blocks contains this particular entity. Right. So that's a simple matter of scanning over what's in here. And actually, I guess I don't have to go through the array count. All I really have to do, because we've got a member in there that actually counts them, is I can just use that entity count that we've got. I can go through there. There we go. And I can say, for each one of these, if the block contains the entity, right? Like so. So if we found a match, then we know we can just remove it from this particular list, right? And the best way to remove it from the list, right, is to swap into this location whatever the sort of highest entity is. So we want to do that same trick we did before.
Okay, so I kind of thought maybe this is how he would do it. So this is the part specifically that I was wondering about when we started writing this little branch here, right? So we find it, and then in here, I'm trying to remember exactly where that was. Was that back? I think that was also in the get world chunk proc. So, was this it? Man, I can't remember. I know we did this in the way that he's going to do it one other time, and maybe he'll just mention it outright where else we did this. In fact, maybe he just did. I'll just back up a few seconds here and make sure that I got all of that. But at this point, this is where we'll go ahead and do that swap, right? Thus pulling it out of the old chunk. And this should be less than, right? I think so. Okay.
Is to swap into this location whatever the sort of highest entity is. So we want to do that same trick we did before. Basically, I don't know if you guys remember this. We did this, I think, on the high entities. What we have here...
on the high entities. Okay, so if I go into main here, because I don't think we're doing any entity stuff in the world file yet. This doesn't look like what I was expecting to see. I think this is it right here. So it would be in the... I see. So yeah, taking a high entity and making it low frequency, right? And we check to see that if the high entity index that we're passing in, or that we're trying to make low frequency, right? If it does not equal the last index in the high entity count, that means they're different. And we take the last one, and we take the deleted one. We take references to both. we point the deleted one at that last one, and now it's gone out of the high entities, right? So if I was to try and do that, if I was trying to write this code before Casey does it for us here in a few seconds, maybe it would help if I was looking at both at the same time. I don't even know where I'm at for time on this episode. I haven't looked. We're about halfway through the day. What time is it? How long have I been streaming for? Okay, so we're doing okay. What tends to happen is it takes me about an hour to work through a half an hour of an episode. So each stream is landing at about the 2-hour mark, depending on how much coding there is. So I'm like right where I want to be. And so I kind of just want to take the time to see if I can do this myself before Casey shows me, so, especially since we've already done it before, right? Let's go back into that low frequency procedure. And then we say, okay, so if we found it and if it's the last one, well, it's a little bit different. The situation is a little bit different because it might not be, well, whatever its index is. Let me see. Let me think about this. We had the low entity index, whereas down here we had the last high index, and we were comparing those. What we care about here well, they're already sorry, I'm just trying to think through this because I really would like to try and implement it correctly in the way that he's talking about, and he's about to blackboard it, so it's not like we won't get a good explanation after this. But if I don't think through it myself, it just won't stick. In this case, we're checking against two indices, and here we have each index in that block's low entities, and if we find it, we know we have that entity. So we want to take the last one. The case that we're worried about is if the last one is the one we're on. There's no swapping that needs to happen. Is that right? So it would be like if block entity count equals index. But I don't know if that's quite right. It would be if index equals entity count minus 1. If I'm not mistaken, right? So that's the thing. That's the condition that we want to be worried about, because if we do the swap on, and it's the last index, then we're swapping it with itself, which means it's not actually going to be deleted, right? I think that's right. So if that's the case, then all we'd need to do at this index is just say 0, right? Otherwise, then we can do the swap kind of like we're doing here and say, give me the last entity out of the block. Or is it, yeah, is that right? Well, we didn't pass the game state in here, did we? Yeah. How are we getting at the, it's like hard to put all the context of like, do we have all the context we need here? I think we do. I'm just having trouble thinking through it. I think we just need to swap the indexes out, right? Like we don't want to actually get at the actual entities, which is what we're doing here. We just care about swapping the indices. I think that's right. So last equals block, low entity indices at the entity count -1, because that would be last, and we can just say over here, last index equals this. Need to declare that. And what is going on with last here? What's the matter? What I do, OLS? Oh, declared but not used. Okay, that's fine. So we get the last one. And then the deleted one is, well, it's going to be this. This is surely not the way this is going to look, but I think this is basically right. All right, this is the one that we're deleting. And like all we would need to do is say that at the current index that's pointing to this deleted one, we just want it to point at that last index instead. It's kind of weird because it's a it's a list of indices, right? And then we're iterating with an index because there's just a lot of references to something called an index happening all at once, and it's kind of confusing the matters. But I think this is basically it. In which case, I don't know if we really need to. We actually don't need to do this, and the only reason is because we're not dealing with the actual entities themselves and having to, you know, do pointers and stuff. I think we're just swapping things there, and then we're good. Maybe that's wrong. Maybe it looks a bit different on Casey's end, and it's right. I don't know. Let's find out, because I don't know if it doesn't seem obvious to me that I'm screwing some aspect of this up.
Is we've got sort of a series of blocks, right, that go like this. And each one of those blocks sort of has inside of it 16 things, right? So each one of these blocks has lots of things in it. When we find the one that we want to remove, what we'd like to do is always keep the empty space at the head of that list, right? We always want to keep the empty space up here. So what we'd like to do is when we find the one that moves, we would like to go ahead and say wherever our head end list was, right? When we get rid of this guy, we'd like to grab something from the head of the list and put it into that space so that this decrements downward, right? So that we always keep our free space at the beginning so that when people try to insert, they can just insert the head end. They don't have to hunt to try and find free space. Now, we could do it the other way around. We could do the hunt here. But since we're already hunting, in this case, we've had to hunt through to find the entity in the first place, it seems more sensible to do it here than to force the hunt a second time back here. So what I want to do is say, all right, when we find this entity index, then what we're going to do is say, we have two circumstances that could be in play here. One is that we are the head block, which basically means that we're just going to reduce the count on the head block. Or in the other case, we're some other block, in which case what we're going to do is we're going to reduce the amount on the head block by grabbing something from the head block and putting it in here, right?
And I guess that's one thing that I did miss here, right? Is if we do either of these things, in fact, that reminds me, I think down here, where was that? Wasn't it in here? Right here, I forgot to increment the entity count on the block. And the reason I forgot to do that is because Casey is doing it like this, right? He's doing that increment after this whole operation takes place. Wouldn't be the first time I've had that bug. So yeah, right here, entity count should be decremented. And hopefully that's right.
So what I'd like to do is say, okay, got it. Let's see if chunk first block equals block, right? So in this case, we're going to say if we're on the first block itself, then all we really need to do is swap with the last guy in here. And I don't...
Okay, so I picked up on that when he mentioned the fact that, you know, if we find the entity way down the line, you know, let's say basically any block, doesn't have to be way down the line, any block after the first one. I think all I've written here is the case that accommodates the first one, assuming that's even right. So if the address of the first block in the entire chunk equals the current one, then you would do all of this. Otherwise, it's a little bit more complicated, because then we need to take, well, if it is, you would just do this, but if it isn't, you would just, instead of working off of the current block, you would just work off of the first block for doing this stuff, right? We'll see.
Really know. I feel like I could write this code to just be very aliasing and let the compiler. I think we don't have anything turned on that's going to assume no aliasing like that. So we may be able to just let this ride without having to do the check. But I'm going to break it into two cases at first, and then we can collapse them later if need be. So what I'm going to do here is say, all right, if the first block equals the block, then we just have one block to deal with. So all we're doing here is we're saying that the entity count on the chunk that we're on, right? Oops, block. The entity count is going to go down, right? And when the entity count goes down, what I want to do is I want to take whatever was at the end of the list, and I want to put it in the location where I'm removing this guy. So basically, the low entity index, right, of whatever this guy was. Well, I actually have one other thing that I want to do, right? I want to see if that first block, and, you know what, I think I'm going to introduce an actual pointer here called first block. So I'm going to just go ahead and do that. So I can say first block equals chunk first block, right? Like so. So what I want to do is I want to say, okay, first things first, if there was only one entity in the first block is really what I should be checking in this case. So if the first block equals a block, if the first block entity count equals 0, or I should say equals 1, right? So if me removing this guy is basically going to cause this block to go away, then what I need to do is something very special.
I didn't even think about that. If the first block only has one entity in it, then you actually just want to wipe it out altogether, because otherwise you have this empty block sitting around taking up space for no good reason. Shoot. Yeah, there's a lot of aspects of this that I didn't think through, but I'm glad I tried to think through it a little bit first rather than just copying the answer, because it just led me to make a bunch of bad assumptions, you know, about how this is going to work, and then having those proven wrong just makes it makes what I'm actually trying to do that much more tangible, I guess, if that makes sense. So in here, you know, that's the same. I think I got that part right, or maybe he had already written that, and I'm taking credit for doing nothing right at this point. So if we're on the first block, then good, but down here, well, he was decrementing the entity count, but he hasn't. I guess he took that code out. With the first block, entity count equals 1. And now we can continue.
What I need to do is say, okay, if there was a next block, that block is now going to become me, right? So basically I need to say if that first block next is valid, then the first block itself becomes the next block, right? Because we would be getting rid of this block entirely, it just goes away. So I want to pull that next block up into where I'm at, essentially getting rid of one of them, right? So that finishes that off, but I have one other thing that I need to do, which is we had memory stored for that next block. I'd like to reclaim that, right? I'd like to be able to use that for further empty block storage, right? So the world empty block, next block, right, is going to be equal to this. We're going to set that equal to it there. And then what I'm going to do is say, well,
this is getting pretty nested. I'm halfway across my editor now. Okay, so if we had, okay, so right here, if we have a first block at all, then we say, or if our first block has a next pointer, Then we point this at the next one. Uh-huh. Okay, I see. So, and it's because we want to keep this around to do something with it, which I think is what he was just saying. So we get that pointer out and dereference it, but now we've still got that address hanging around.
I can go ahead and free that block. So I'm going to make a note of that here because we're going to talk about what that does in a second, but I'm not actually going to implement it for another couple seconds because I just want to work out what all the cases are here for doing the storage the way that we're doing it first.
So he's going to have to write that, he's going to have to write that free call, and I don't think I will because we're just using, the context allocator and all that stuff. But that's just kind of a nice win. More and more, I feel like that was the right choice back at that, point in the code where we decided to use virtual arena out of Odin's mem package. Okay, so far so good. We'll see if the rest of this, because it basically hasn't gotten around to this case, right? Or he hasn't gotten around to implementing the rest of it. So we'll just let him continue.
So the first block is the block if the entity count equals 1. If the entity count does not equal 1, that means that we have an entity that we can shuffle into this place. So all we're going to do is we're going to take that entity count, and if you imagine what we're doing here, again, it's very, very straightforward. Oops. I really wish that it would not do that. I feel like they should fix that bug. It's a really bad bug, and I feel like you had to have known that it was there because it's anyone who's ever alt-tabbed to your program will experience it. I'll have to send them an email. Okay. So essentially what we're doing is oops. Pick it, there we go. Essentially what we're doing is we're going to go ahead and say, all right, we've got some number of entities in here, right? And again, entity count would basically be pointing to some, this is the count here, right? We point to some location that doesn't exist at the moment. We are looking at some location that does exist. And what we want to do is say, all right, we want to reduce the count by 1, so it'll now point here, right? Excuse me. And what we'd also like to do is we'd like to move whoever was there into the location that we have, right? Does that make sense? So all we're trying to do here is say, okay, whatever that first block low entity index is, wherever entity count will now be pointing to, we want to make where we are at right now equal to that. So use the space that we are pulling the entity that we're removing, we're pulling them out of that, use that space to store whatever was at the tail end of this list, right?
Okay, so we just did the decrement elsewhere, and he also did it off the first block, which makes sense because that would be the block that we're on. Make sure I'm actually looking at the right thing here. Okay, so that is still happening. And think about this. He did all of this, but much more simply. And I need to figure out why that works, right? But basically, it's the same thing. Yeah, no, maybe my thinking about this was all wrong. So he does assign this to be first of all, he's doing all of this with the first block. So let's just change all of these to be talking about that first block now. And there's no last index, or at least maybe not yet. So maybe I'll just do this. Maybe he hasn't gotten to that case yet, but we're not dealing with the last. We're going to do the decrement over here. And this is just going to work like that. Instead of it being on the last index, it's going to be off of the current block entity count. And actually, he does decrement it first, so I don't know where my decrement went, but let's just do this. And we have to do it first, because otherwise we'd be indexing out of bounds. So we decrement that. And then we say, whatever the current index is, point it at the end. Okay. Shoot. Yeah, that is much simpler. Because if it was at the end, like if... Yeah, I know. Well, this just makes sense to me, and now I can't even track why that other way I was trying to think about it doesn't make sense, which is disappointing. I thought I knew what was going on, and then I didn't. And this also, let me see here. This needs to be tucked underneath this else. So if our first block equals the current block, and we're emptying it, yeah, if we find the entity we're looking for in the first block, and that first block only has that one entity in it, then we can just get rid of it, which is fine. And then down here, this is the thing, I mean, this is the thing that I knew we had to solve, and I still got it wrong. Like, I'm trying to think of the case where the index we're on, the index where we find it, is the last one. That's the case where I'm trying to think of, like, why this still works if we do that. And maybe it doesn't, we just haven't gotten that far yet. But let's say that this value here, now the block entity count equals this value. Right, like we've gotten to the end. That would still leave it in there, wouldn't it? Yeah, it would just be, if this value is now, after decrementing it, is equal to this, well, I guess, yeah, if it's equal to index, yeah, I'm gonna have to like draw this out or something for myself to really understand, because we're decrementing it, so we can never actually get to the count. But if we get to just beyond the end of it, let's say we've searched to index 15, and we see that the block, the index at the end of this block, block's low entity indices, equals the last index, and then we subtract it. We subtract the count so that it's down from 16 to 15. Then we'd be saying the first block, low entity indices at the 15th index. No, is that right? We'll say there's 16. Yeah. So if we've got 15, we've got 16 entities in there, and we get to the 15th index, when we subtract this, it'll be 15, and then we just be assigning it in place. I feel like this still doesn't cover that other case, which would mean that I was thinking about it the right way, at least on some level, even though I missed all these other bits and pieces to this thing. Yeah, we'll find out.
And that's it. That's all we're going to do there. Okay. Excuse me. And so if it wasn't the case, right?
Maybe not, because he's acting like this is good. He's moving on, and it seems like he's not thinking that that's going to be a problem. But I feel like it would be. Right, because then we're not moving it out. Like, we're not overwriting it. We're overwriting it with itself. That's the way it seems to me. So, I guess what I would do is write a to-do, you know, do we not need to handle the case where the index where we found the entity is the last in the block. And if we were going to handle that, right, we would say if, I guess this should go up here. If blocks entity count equals this, then we would just zero it out. Else, we do that. Right? I feel like that's something that needs to happen, but Casey's not doing it, and that either means that he just hasn't gotten around to it, but it seems like he's moving on, and I just want to be absolutely sure that I understand what the heck is happening here. Because clearly we've got a lot of stuff going on. And I guess one thing that I'm glad for is that I wasn't able to think this through intuitively. Or at least I'm not mad at myself for not having an intuition about it, because look at how much stuff we have to wade through, right? Just to get to the actual place of concern. It's a lot of walking down, you know, this linked list with these world entity blocks, and it starts off in the chunk. I mean, it doesn't seem that complicated on its face, but once you drill down and you think about what you have to actually do, I haven't done enough of this kind of work to really have an appreciation for the nuance. But doing this a second time through now in Odin, it's coming together a little bit more. So there you go. So now we just need to handle if we did not find the entity in the first block, right? At which point, I suppose this will look pretty similar, actually. But instead of, and this actually needs to be, well, it doesn't matter if we're setting this on the first block, like if we're decrementing it off of the first block, or, you know, the block that we have in the iteration of the loop, but this at least makes it more explicit that we're dealing with that first block. And then over here, we're just dealing with, instead of moving it, I think we still need to handle the case where the block we're on, right? We're going to have to do something just like this. A lot of this feels like it should look the same, but we're going to handle it differently because it's not the first block that we're worried about. I feel like this could have just worked generically, whether we're on the first block or not, but it wouldn't. Yeah. Like we would still use the first block down here to set where that new, or reassign where that low entity index is off of the current block at that current block's entity count after we decrement it, right? just trying to think about where this is going to go and how this will all come together.
If that wasn't the case, well, honestly, these are basically, it's exactly the same, right?
Okay, I'm so glad that that happened at that exact moment, because I was like, man, like, what's the difference? Why does it matter? You know, the difference is that we aren't going to do this off of the first block. We're not going to assign from the first block's low entity indices, right? If we're not on that first block.
It's pretty much exactly the same. There really isn't anything. There really isn't anything else to say. In fact, we don't even have to do this. If we happened to have been removing it from there, really, I mean, there's really only one sort of iffy corner case that we have to deal with. So let's go ahead and just write them as 1. If the first block entity count equals 1, then we do have to do that shuffle there. But really, the only thing is this guy. Well, I don't know. Maybe it's clearer to write it this way. You can see what I'm kind of grappling with here. If we know that if it's only the first block, then we know that we can just do this and we don't have to do the copy because we know that there's no room left in the first block. But if we actually were to the first block, then we essentially have to do the same thing, right? I was trying to condense them, so let's just blow them out first and see. If we know, excuse me. If we know that the first block was not the one we're on, but it still has that, then we need to do that copy again. But what we need to do first is we need to salvage that entity first. So in either case now, what we would do is this guy always, right? So what we'd want to do is say, okay, whatever the first block entity index is there, we're going to copy it from the block that we're on now because they're different. And we're going to go ahead and reduce that block entity count. Oh, sorry, did that backwards. We're trying to copy it into this location, the one that we're on, the space that's now free. We're going to go ahead and grab whatever that last one was in the first block. And then if that block count has now dropped to 0, right, as a result, then we're going to go ahead and do the free if necessary, right? If it happened to have something down the road from it, we'll grab it.
Okay, so this, there is no else, first of all. It's hard because I'm looking at like the C code and then the Odin code, and it's a little bit much. It's a little bit much. This is like one of the first places in doing this stream where I feel like I'm getting really hung up on the difference between the languages, but it's really not that bad. It's just that it's a very kind of ephemeral problem space that's hard to conceptualize. So if we have no entities in there this time around in the first block, well, that's kind of weird. Yeah. Okay, so this changes like that. And we do the decrement first. And actually that decrement does have to happen on the first block. Is that right? This is going to bear repeat watches without, hands-free, no writing code, I think. All of this can just go away. And this actually, I guess, should be on the first block too. Now we're wrapping, which is just not fun. I didn't think that we would have code this far indented, or at least I thought, I don't know what I thought. I didn't expect to run into this problem, honestly. Whatever. I'll think more about that later.
So I guess what I was going to say, though, is I would like to collapse these. I'd like to get rid of this. And so the question is there anything special that we have to do? It kind of looks to me like this just works no matter what, right? I mean, it doesn't really look like there's anything else. If it was the first block and the entity count, it would just copy the 0th index over itself, which is fine, right? So it doesn't really matter. So I think we can just say that after all that, after thinking it through, really that's it. That's the entirety of the code. That's really all we need to do, right? And I don't know if I've got bugs in there, of course, maybe I do, but that's it. And once we find it, we can break out of there, but we've got to do a double break here, unfortunately, because we essentially have to, we kind of got to do something like this, because.
Okay, so it looks like he's decided, actually, after all, that this can go up here. Of course, we'll see if all of this holds up once we actually go to run it, right? But still wrapping, not great, but that's going to go away. Yeah, I'm gonna have to sit here carefully and study this code and really think hard about why we seemingly don't need to be worried about this as far as Casey is concerned. But, and also now we're checking to see if we have an entity count of 0, which, okay, yeah, because we did this up front. So there you go, after this takes place and we've done the assignment. Then we can free I see. We're basically taking that first block and then moving it, getting rid of the old first block and moving the next one up. In the case where we do have a 0 count. Okay, now I understand why you changed that. And we're doing that up front. I'll just move this to do up there. And maybe this will be clearer when I step through this one last time here, now that it seems that we're wrapping this up. Still looking good on time. Okay. So we do that, and we say that this block equals nil. And we break. And then I think we're good. So starting from the top, we start searching through every index in the block's list of low entity indices. With respect to how many indices we're even storing in there. If we found it, then we decrement the first block's entity count. That seems wrong to me. I feel like we should be decrementing whatever the current block is, because that's wherever it is, whether it's the first block or not, that's the one we're going to remove an entity from. And then we say, hey, now at the index that we're on, instead of that pointing at the old entity that we're removing out of this block, well, oh, I see. So that's actually, I think maybe I finally get it. We never worry about this because it's always going to point at, we're just going to keep peeling off entities from the first block. Is that right? So in that case, we're never worried about it being like reassigning it over to itself. But then it feels like then the inverse would be true, and we'd be doing that if we are on the first block, then we could be overriding it to just point at itself. All right, because we still have this issue, at least as far as I can tell. And instead of using like the max limit on the list as an example, let's say that, blocks entity count, probably be easier for me to understand this if I type it out too. Our blocks entity count is 8, and the index that we're on, we've gone through the whole, and actually this would be 7. We've gone up to the blocks entity count, which is 8, so that we're on the 7th index. And that's where we find the low entity index that we're looking for. And then we decrement the blocks entity count so that at this point, it equals 7, right? And to be honest, this would be a lot easier if we just kind of like went through the code with Casey and then finished writing it, compiled it, and then I had like a debugger set up, and then I could just step through this. But then I'd have to like recreate that count. So maybe it just does make more sense to work through it in my head anyways. So at this point, whatever the current block is, we say at this index, which is now equal to the entity count, we set it to be like make this totally explicit, right? Whoops. The issue that I think I'm seeing is that we're assigning this, and it doesn't matter whether if we're on the 7th index and the block now has 7, we're just overriding itself if this is the first block. If the current block is the first block. Otherwise, then it would do the well, man, I feel upside down in my understanding of this. I feel like I'm just close enough, but so far away. Because if these two blocks are separate, if we're not on the first block, and therefore the current block is, somewhere down the chain, then it doesn't matter that there's the same indices, right? Because it's coming from the first block. But if this is currently pointing at that first block, then we'd be overriding it with itself, instead of setting it to 0 like I think we should be. And therefore, we'd have this, index floating around in 2 different chunks that point to the same low entity. So I feel like that's still a problem, but somehow maybe it's not. Maybe that's a bug that will pop up right away and be, and Casey will handle it immediately. So after we've done that assignment, get rid of this. We check to see if we've now I don't know. Should we be decrementing off of the first block? Or not? That's what he does, so I'm just going to do what he does. But anyway, so if after we've done that, we peeled off the last entity index from the first block, we check to make sure that's not nil. Or we check to make sure that the next is not nil. Well, that's kind of weird. Why would we have a next that is a nil pointer if... Oh, okay. I think so. I don't know. Man, this is tricky. If we go back over here, let me just look at the actual types again. Yeah, we could be freeing the memory that this first block points to, which I guess doesn't make sense to me. Oh no, never mind. We would never do that because it's always off of the next. It's if we have a next. Excuse me. And then we'd be just saying, okay, never mind. Scratch all of that. I was wrong about that, but I'm still confused about this. So I'll stop talking about it finally, and I'll think about it some more if it doesn't come up again during the rest of this stream, and then at that point I'll talk about it on tomorrow's stream. Maybe I should draw it out like Casey. Yeah, I mean, I think typing it out, I should have started doing that sooner, but the code kept on changing, and so I was like, you know, working with a stale idea of the code in my head, like constantly as it was shifting around there. Yeah, I probably will draw it out for myself, but I think I understand. Well, I understand how this is all working. I just feel like there's a case that we're not handling here, right? Which is that these are, if we're on that first block, then we're overwriting. And instead of like reassigning an index, we're just overwriting it with itself, which leaves a stale index hanging around. But we'll see.
We have to be able to stop searching through the blocks as well. We don't want to waste time searching through blocks that don't actually matter. So really what we have to do now is just address what happens when you free a block. And this is one of those memory management things, like I said. People don't usually believe me when I say that I don't spend time thinking about memory management.
Like I said, we're just going to use the free that we get for free by just using the context allocator that we set back in the game initialization code. So, but it's still worth it to think about, you know, how you would implement this yourself, I guess. So I'll just let Casey show us how it's done.
And I really just don't, because it seems like most of the time it just sort of handles itself. Usually the things that I do spend time thinking about are things like this, where I like to actually work on the data structures themselves, because I like to think about how things are being stored, and I like to play with those and make things that are custom built, as opposed to just using a generic array and just throw things in and call like search or a map or something like that, right? I like to do that sort of stuff, and so that is definitely something that I do spend time doing, although as you can see, not that long. I mean, how long did that take us? 30 minutes? I don't know. Not very long, but I still like to do that. But the memory management part of it, that's the thing that people bring up so often, is so free compared to the rest of the thought that I put into any particular system, that I'm surprised it's the one that always comes up. Because in this case, we have that exact situation, right, where we've got memory that's being used for these entity blocks, and we need to make sure that we conserve it. But it's so easy to just, I mean, this is the entirety of the memory management we would need, right? All we would need to do is say, first free, right? There's our...
Sorry, I got to respond to a work ping that I got a little while ago. Nothing like a little bit of context switching. Normally I don't get anything going on this late in the day, but it does happen sometimes. Okay. Seems like my coworkers have it handled, but there was a question that I think only I had the answer to. And I needed to help them out. It doesn't feel good to feel confused about something that you don't understand.
First free block. And when we free a block, we just say, okay, the world first free equals that block that we just freed, and its next pointer is going to be whatever was there, right? So we're basically going to take that, and instead of where it was chaining off before, we're just going to stick it on a chain that's on the world thing. And then, like I said down here, when we do this push struct, instead of doing that, what we're going to do is we're just going to say, okay, the old block actually is going to be equal to whatever that first free was in the world. So we'll just grab whatever's on that free list. If nothing's on the free list, meaning we don't actually have anything on there, I'm gonna move that up there. We don't actually have anything on there, so if not old block, right? Or I could even say if old block, right? We'll do it this way. Like so. So if we have an old block, then what we do want to do is say, okay, then world first free is now going to be equal to whatever the next thing was on the free list, and otherwise we're just going to allocate, right? And that's it. That's the entirety of the memory management for the system, right? It was absolutely trivial. And maybe I made a typo in there. Like I said, when I talk on the stream, sometimes I can't concentrate that high, but I almost never make mistakes in those. If I do, it'll take us 10 seconds to find. I mean, we only have to step through two. There's all of 4 lines of code involved in the memory management for this thing. And now there's never a call to an allocator. There's never a need to serialize. There's never a need to have allocation at runtime. It just works, right? And yeah, so again, I wouldn't ever really call that out or make a big deal out of it. I would have just typed it in, but I just kind of wanted to emphasize that that's what it feels like to me, because when people ask me these questions a lot of times, I don't have a good feel for where they're coming from, because in my world, that's the extent to which I think about memory management. It was like that 5 seconds at the end of something that took me 30 minutes to think through how exactly I felt like everything should work for a number of other reasons that were all very complicated, like spatial queries and how often something's going to do something, and I was thinking about how to get a good first pass design that I could work, all that stuff is so much more complicated, and there's so many more trade-offs. The memory management part is like irrelevant. It's like 10 seconds of typing and maybe 30 seconds of debugging later to make sure that it worked and you didn't make a typo, right?
Or if you come from a world like mine, where I've just pretty much always worked with garbage collected or dynamically typed languages, or both, that, where essentially all that stuff is obfuscated from you. It's just not something that you've had to think about. I haven't had to think about it all that hard since before starting Handmade Hero, since, those lower level like operating systems classes that I took in school. And I actually, ironically, I enjoyed those classes quite a bit. I don't think a lot of my peers did, because it was the material was a little bit, it was more like this, a bit lower level, but it certainly didn't look like this, where you were implementing your own memory management essentially with Arena. It was literally just like knowing when and when not to malloc or new or delete or free and all this other stuff. But anyway, so the way that he's doing this, and yeah, so at this point, after we've said we have our new first block is pointing at the first block's next pointer, the current first block's next pointer, to like basically overwrite it and say, now this is one step further in the chain, or in the case where there is no next pointer, then we just wouldn't do that, and we just have a completely empty block. There's no entities in that world chunk. But in the case that we do have that, we look at that next block's next pointer. Okay, and we say this is going to be whatever the first free pointer is on the world. And then we say, then we reassign the world's first free. And then down here, if we had an old block that was set, right? So that means that this code has to execute before this code can ever be executed, right? Hello, Yasin. Sorry, I don't know. I'm trying my best. Yasin, thanks for dropping by the stream. Otherwise, we allocate. Yeah, so if we already have that memory hanging around, then we can use it. Otherwise, we allocate. Seems reasonable to me, but it just looks a bit different for us because we can just do that here, and then, you know, if we need to, then we just allocate the new one with new. So I don't see any reason why this would behave any differently. The details underneath the hood are, you know, gonna escape me. I'd have to go dig into Odin's code to figure out exactly what's going on there, but I think I'm fine having this difference between mine and Casey's code.
And that's the end of it. So that's it. Yeah, and there really isn't much left to say. So that is how roughly we'll do things. Again, like I said, there's a bunch of, it's a fairly nuanced piece of code we just wrote. I'm sure that there's some typo/bug stuff in there. Oh, we forgot to do X, we forgot to do Y. So I think it's a good thing to start testing it out, just play around with it a little, make sure that we got it working. And we've got a bunch of other stuff that we sort of said in the meantime, and we've got to go do that as well. So we might as well start that process. I don't think we'll finish it probably in time for the end of the stream, but we might as well start it, and then tomorrow we can finish it up, and then our spatial queries are pretty much done. So that's pretty cool. So what I would like to do is say, all right, we've got rid of the chunk shift and mask and dim and all that sort of stuff. We've gotten rid of that. So we just got tile-sided meters and chunk-sided meters. And the chunk-sided meters, you know, is just going to be something we'll have to think about what we actually want that value to be. We don't really care at the moment. We have to do that. We also would like to set our first free block to be 0. And when we go ahead and set up these chunk hashes, I would also like to go ahead and set those first block entity counts to be 0 as well. And again, this is just so if we're using some memory that wasn't initialized to 0, which might be true on second, third runs through the game. We want to make sure we initialize that properly. So I went ahead and did that, and off we go.
So I don't think we need to do this. I'm pretty sure anyway. But I'll do it for posterity till I feel very comfortable not, you know, 0 initializing something when Odin should be doing that for me anyways. All right. If we have ever allocated a block, it should always be 0 initialized by default. And so maybe I'll just comment that out for now until I'm fine with deleting it.
So now, when we're doing the rest of our stuff here, we can sort of think this through a little bit. We don't have to do get chunk position for anymore. We know that that's gone. So really, our spatial partition is really just a hash table plus a sort of daisy chain of.
I think he just deleted that. I thought he was going to do something else with it, but turns out he did not.
Chunks. So I guess we've got that straightened away pretty well. I think at this point we know that these do not belong in a positioning or geometry file because they're really pretty intimately tied to the concept of the world storage. So I think that's probably the appropriate place for them as well. So now what we just have to do is kind of start talking about these other things here that we've got. We had a new sort of sense of R on same tile. We wanted to change that over to be R on same chunk. And so let's go ahead and see. I know we called that somewhere. R on same. Oops. What did I do? There we go. Same chunk. There we go. So we'll change this to R in same chunk. We take 2 of them, and basically this is just going to change that abs tile to a chunk. Oops, that's not what I wanted. Abs tile to chunk. So those are replaced, and that is the definition of whether something's on the same chunk. Now, I should probably assert here when it does the check that these offsets are within bounds, and that because otherwise the test would fail, so we're kind of assuming this is true here. So what I kind of want to do is say, let's go ahead and assert is canonical, right? Let's make a function for that. And what is canonical do, right, is canonical, we'll just take one of these sort of one of these positions here. It'll take a I guess a tile relative offset, right? So it'll take a real value that's basically just like this. Oops, tile rel, and it will go ahead and say whether this is working or not, right? Fixed floating point mass of this can be exact. How are we getting away with these being greater than? When did I switch from it being that? When did I switch from that? Because that technically shouldn't be possible. You should be able to end up. You have to be able to end up exactly on it one way or the other, at least in one of the directions. I don't know why we did that. All right.
I wish I knew. So it turns out he had not changed this. I thought maybe he did, but he wrote a call to this, which didn't quite exist yet, and then he just kept on going, which I am too obsessive compulsive to let that go. So I already changed that. And then this is just going to be chunk X and Y now. And if we go to here, you know, I don't know if he's going to plan on working on this to do soon, but we're going to go ahead and do what he did and add this is canonical procedure. And before we finish that out, I wanted to move this. Well, did he move all of that stuff? Well, where is my get world chunk? Whoops. Okay, so that's all the way up here. I thought maybe he had moved this big ol' procedure that we just spent pretty much the entire stream writing. Thought he had moved that up, but maybe not. It probably just doesn't matter much, but I find it easier to navigate around if I kind of stick more closely to the way he's structuring things. Okay, so this is going to take the world, or a pointer to it at least, and then that tile relative value, which is just a float, and we don't need to dereference this. Pass in the world, pass it in, and dereference it here. And this does not return anything, but I guess it should be returning a bool. What do we want to do here? Well, I guess I'll let Casey finish. The algorithm has chosen you. Well, you still had to click on these, so thanks for clicking on the stream thermometer.
Yeah, that's, well, we've got a nice little to-do on there, so we'll leave that to-do on there. But anyway, is canonical.
Okay, it is going to return a bool. And I don't know, I mean, seems kind of strange. Are we just going to return true here if we manage to not blow up the procedure with these asserts? What? Oh, I didn't finish writing that in, apparently.
Will now basically give us something like this, right? Where we'll say, all right,
okay,
it's canonical if both, if it's within the bounds, right? And so now we can sort of say we've got that test, and we also will do one where we do, are these always done with v2s? No, they're not, because they recononicalize code separately. So we do want that to be separate, so what we'll do is we'll make a separate one here. It's basically that, which go ahead and says that the result equals is canonical, world offset x, and is canonical world offset y. There we go, and that'll return the result as well.
Say what? Okay. So he's overloading is canonical. And just trying to clean up the code, I suppose.
Always done with v2s? No, they're not, because they recononicalize code separately. So we do want that to be separate, so what we'll do is we'll make a separate one here. It's basically that, which goes...
Oh, man. Okay, so we'll just do a procedure group. We've done it before. We can do it again. And we'll say is tile rel canonical and is offset canonical. That's probably an okay way of doing this. And then we would say that for this one. And now we need the other. Is offset canonical. And so that's going to take a v2. How did I get here? There we go. And then I guess this is just going to wrap a call to this using each of those individual elements, right?
Go ahead and says that the result equals is canonical, world offset x, and is canonical world offset y. There we go. And that'll return the result as well. So now I've got the ability to just kind of ask at any time really easily whether or not these guys are canonical. I'll stick that up at the top. And then when we do that recanonicalize,
okay, we'll just finish this up. So we'd call that like that, and then do it again. Get rid of that. Get rid of that. Okay, so did he get rid of that to do? He did not. Not yet, anyway. And then we want to return the result. I guess I just don't know where else we would call the offset version of it. I didn't even know we were doing that anywhere with an offset. But clearly he knows something that I don't. I feel like I can just get rid of this at this point, especially now that we've gotten rid of that chunk dim member. Just trying to work through the errors that I see as I see them. There's probably a bunch in the main game package, actually. Yeah, all the abs tile stuff. Is that right? What else? Right there, right here. Over here. Whoops. Do I just go for it? This kind of looks like it might be the rest of them. This might be all the rest of our errors, actually. So, yeah, let's just go for it. Oh, no. Well, is that okay? D chunk Z. Is that fine? This might not be right. I don't know. We'll just go for it and see. This is going to be like yesterday where it just works. First time. No way! That's unbelievable. Surely we should have broken, but maybe it's because we're not calling that new procedure that does all that crazy stuff anywhere yet. What was it? Change entity location. Yeah, I don't think we're calling that anywhere, are we? Yeah, okay. So let's not get too excited yet.
Anytime really easily whether or not these guys are canonical. I'll stick that up at the top. And then when we do that recanonicalize, where's that recanonicalize chord? We can do that is canonical check on the tile relative position, and I think that should be good there. And that way this guy can also basically guarantee to whoever's calling him that it had been it had been canonicalized before it was checked. Right, so basically we'll pass the world in there and say, okay, we'll double check that, make sure that it was canonical first, because otherwise we know that this would fail. Right, so we've got that like so, and there we go. So we'll double check those. That seems good. Let's see where else we're at here.
Okay, so I had missed that. He wanted to add a check here. Is that right? Yeah, on both of these before asking if they're in the same chunk, which just looking at it makes a good deal of intuitive sense. You want to be able to catch that before you get into weird issues where you're like, it says they're in the same chunk, but they're not. Like, what's going on here? Yeah, so just do that, right? And this needs to be, well, there's a trailing underscore on those members. And we're not passing in the world somehow on this. Did he just make that change? Yeah, he did. Okay. And wherever we're calling that, I need to pass it in now. I think that's pretty much the only place. Okay.
Double check those. That seems good. Let's see where else we're at here. Our get world chunk, chunk dim, tile count is no longer even a relevant thing. It doesn't matter at all. So off we go with that. And now we just have to do, we have to fix our recanonicalization. Now our recanonicalization can literally just think of them the same as they were thinking of tiles. There's really nothing else that we have to do here. Essentially all we're going to do is just change from thinking in terms of tiles to thinking in terms of chunks. So really that just involves me doing this, right? It just involves me doing this. And similarly our recanonical...
Hold on. So actually in here, yeah, this is based off of the, okay. It felt a little weird replacing tile with chunk. But that makes sense now because we're doing the calculation based off of the chunk's size rather than a tile. And I think this will actually stay the same.
Involves me doing this. And similarly...
Or not. Well, I guess because it's relative to the chunk, so yeah. Yeah.
Are recanonicalized, right? If we want to switch to that, we just do chunk side in meters. And now I think basically everything is going to be chunk side in meters. Oops, tile side in meters. There we go. So now we just have to go ahead and say, all right, these are all going to be the same as well. Chunk side in meters, chunk side in meters, right? And so tile side in meters is literally used nowhere in here now, which is what we want. So the recanonicalize now will work properly to canonicalize in chunk space instead of tile space, which is what we want. Basically, just think of them as giant tiles.
I can get behind that, so let's look for any other places there. We're doing it here still, but I saw him change that, so that gets updated. Why do I have... Oh, no, that's in the same proc. Okay, I was like, why do I have two of these procs? That doesn't seem right. So that's good, and that's good, and we're good.
And there's just lots of entities in any given tile that make up the character of the world. And we've done that. Centered tile point is not particularly useful anymore, but I guess we'll leave it in there for now in case anyone's actually calling it. Is anyone actually calling it? Let's see. Well, actually, I guess I can just do a compile. Let's find out this way. Okay, so for subtract, this is again just the abs tile becomes a chunk. So there we go. Let's see what else we got here. Same exact thing. Abs tile equals chunk. And this is actually a centered chunk point. Yeah, so I don't even want that. That's not going to be a thing that anyone does, is it really? I guess, well, yeah, who knows. Let's call it centered chunk point, and we'll just see. So we'll take abs tile and change that. There we go. And our insane chunk now needs to take the world, I believe, is the only difference there. Our insane chunk world position. These are taking pointers at the moment. Not sure if we care about that, but off we go. And so here we are with having to do our Z position. We need to think about that for a minute, but we can for the moment. Change that to be the chunk Z, but we want to think a little bit more about that because right now we don't support offsets in the Z direction, and I think we want to. So that warrants a little bit more thought. We're pretty much out of time, so let's go ahead and finish cleaning some of these things up here.
Okay, so I was wondering about that when I saw that. You see, when I saw this changed to D, I was like, let's just do it all. Let's change it all, and that was actually not the right thing to do. At least not yet. But the point, I think, is that we want more granularity in the Z direction than just which chunk we're on, right? And I don't think that actually changes, so we'll try and do that and revert that change where it matters. Which is only a couple places, so not too bad. Dang it. There we go. There we go. And actually, oh, well. Okay, so he doesn't address that there, but this is now just that, maybe. Maybe that's all that needs to change. right? Because we don't have an ab style Z on the world position anymore. So we'll see what happens when he goes to try and address that.
And so here we are with having to do our Z position. We need to think about that for a minute, but we can for the moment change that to be the chunk Z. But we want to think a little bit more about that, because right now we don't support offsets in the Z direction, and I think we want to. So that warrants a little bit more thought. We're pretty much out of time, so let's go ahead and finish cleaning some of these things up here.
Well, we were working and now we're not, which feels more appropriate, honestly. It's more comforting to know that it's broken, because it means I for sure did something wrong, versus it running fine and us believing we did everything right when surely that can't be the case. So yeah, something about this feels very fishy.
I'm not sure what I want to do here for these guys. So these are creating entities at those locations, and we do know how to create things at a particular tile location. So what we could do is actually just allow it to map those in there. So maybe I'll just do that for now. That'll be the easiest thing to do, so I'll do it that way. What I'd like to do is say that recanonicalize, right, that we can call. Where is that? So recanonicalize, there should have been map into tile space. Where's the actual, did I accidentally delete the one that calls this guy? I think I accidentally did. That's my bad, didn't mean to delete that guy. I actually thought he was totally fine. Map into tile space is essentially the function that we actually would want here. Yeah, well, hold on a second. Let's think about this just a little bit more. Okay, so if the camera filing entity, yeah, so this is going to be the chunk Z here, right, for now. Let's go ahead and take a look. The abs tile Z, again, so these we're going to have to do some Z handling a little bit with a little bit more pizzazz in a second here, a little bit more thoughtfulness. Chunk Z is not a member of high entity. That's true. That is true. It's not abs tile Z, so that'll be chunk Z for the moment. We've got
What? Yeah, no, that's not right. Yeah, he changed it too, and I don't think he meant to.
not abs tile Z, so that'll be chunk Z for the moment. We've got abs tile X, Y, so these are all going to be essentially ones where we...
Maybe not. I don't know. Let's just do that and keep the code as close to his, because who knows where this goes. I don't.
We have to figure out what the chunk relative position would be from a tile relative position, if that makes sense. And that is a little trickier. But what I could do is just make a function that's called chunk position from tile position, right? Something like that, and then just pass these in, and that would presumably just solve the problem for us, right? Like so. So let's.
Okay, so these were not supposed to change. And that's bad. Why didn't I leave spaces in that? There we go. Chunk position from tile position, which we do not have. So, okay. Chunk position, we'll just say chunk pose from tile pose. Just checking to see if he passes in the world, but it looks like he does not. Maybe he'll have to. I don't know. Who knows?
Go ahead and take a look at that. We don't have that yet. Yes, I know. And if we do hit high entity index, so this is not actually done yet. We're not going to do that yet. This is stairs, basically. Abs tile X. This is searching. So the set camera now will be. This will actually be a thing that we can do in tile chunk space. So I'm gonna vaporize this for 1 second, just to make sure that we're compiling, right? In terms of tile chunks. And that's what we'll do, I think, probably first thing tomorrow, because then we'll be optimized there as well.
Hey, thank you. Do you feel better?
Yeah.
Yeah? I'm sorry. Love you.
Love you.
My lovely wife has brought me tea again. Exactly what I needed. Holy crap, it's 4:30. That's a shame. The day's getting away from me. Okay, so and I was asking her if she was feeling better because she's had a headache all day, and unfortunately, it sounds like it's still hanging on. But I'll be free to relieve her and help her with the kids here soon enough. Just gotta work through these last couple minutes. We're so close. So he was changing something else there. Yeah, he's adding in a to-do and zeroing out this code dealing with all of the ab style stuff. I guess this was just all the wrong thing to do when I changed that. That's what I get for being too hasty. Let's see. Let's replace chunk with abs tile and comment that out. So that math, I guess, is just going to need to be a bit different. Do this in terms of chunks. Here we go.
And that's what we'll do, I think, probably first thing tomorrow, because then we'll be optimized there as well. We got to implement that, and the same thing is true here. So new camera P will basically be equal to chunk position from tile position, and that will just do what it was doing before. And so all we really need to do in order to end the day on a working note is make sure that we actually write this function properly. And I say working note, that's actually a pretty strong statement, I suppose, because we don't actually know if we'll be working. We'll at least be compiling.
He gets like a jolt of energy at the end of almost every coding session where he's like, okay, let's get all these things done right now. We're trying to wrap up the stream, trying to get to the Q&A. And it's always when he does that I'm at like my lowest point of energy in the day. Like I'm really struggling here. Where is this? It's when he's setting. Okay, so we had that dummy entity stuff down here somewhere, right? Gosh, where was that? Oh man, his Emacs did something really weird here that was screwing with me. Can I really just get rid of all of that? Why would I do that? World. Yeah, it gets set there and then down below it. Yeah, why did I do that? I don't know that it'll ever come up again, but it seems dumb. I don't know why I would do that. We'll just rewrite this back in here. Yeah, it was coordinate. No, I did have that. Okay. Why is that here? Oh. Damn it. Okay. Never mind. Well, I guess good news for me. Bad news that I wasted time doing that, but good news that I didn't delete it. Here it is. Okay. So this, yeah, this business here. This is where he's going to do another call to the new, or to the get chunk pose from tile pose, I suppose. Lots of posing.
Be equal to chunk position from tile position, and that will just do what it was doing before. And so all we really need to do in order to end the day on a working note is make sure that we actually write this function properly. And I say working note, that's actually a pretty strong statement, I suppose, because we don't actually know if we'll be working. We'll at least be compiling, and that's what we'd like to be. Leave us.
What did he set that to? Okay, just straight up plugs all of this stuff in. Which is, I almost wonder if I want to calculate those and assign them and then pass them in so we don't have this really nasty long code hanging off the edge of the screen and wrapping around. Abs tile X and Y and Z. Abs tile X, Y, and Z. Rest of that looks good.
What we really need to do in order to end the day on a working note is make sure that we actually write this function properly. And I say working note, that's actually a pretty strong statement, I suppose, because we don't actually know if we'll be working. We'll at least be compiling, and that's what we'd like to be. Leave us in a good place for tomorrow. So all we really need to do is make something that will return a world position from a tile position so that our old code still works. We may never use that, but at least we know that it will work in terms of our testing and testing the same code that we had before. So let's go ahead and do that. There we go. And now we can implement that function. So our result is going to be equal to all zeros at the start. And then what we will do is we will say that our chunk x, right, is going to be equal to sort of, we have a definition up here for probably how many chunks, how many tiles per chunk, if you will, right? We've got this number here. So what I think we want to do is do tiles per chunk, something like that. And we'll say that that's 16. So tiles per chunk equals 16, right? And we'll just leave that up here for now. That could be parameter.
And he is really moving. Good Lord. My brain can't handle this. Okay, so he still hasn't actually done this. I thought he had finished implementing this whole procedure and then just started moving around to this other stuff and changing that. We'll just say this is a world position, and we're going to return that. And this is going to be something here, and then what was it? That 16 value. We're using 16 in multiple places here, so I want to get this right. So that tiles per chunk, yeah, it's actually literally right here where I was at. So tiles per chunk, right? Like that. And are we using that number anywhere else? Nope, just here, just arbitrarily. We have 16 low entity indices in each memory block as well. Or each entity block. Goes from 1.5 to 2 times speed. It feels like it did. Actually, did I somehow do that accidentally? Nope. Still says he's going at 1.5, but you know what? I think my brain is just operating 75% speed, so that's probably all it is. I just can't do it. Only barely. But you know what? It's like the way that I try to think about this, and I felt it slowly but surely happening, is that the more that I push myself past that point, the further I can keep going and still be able to reason about things reasonably. Maybe that isn't true. You know, there's of course always limits, and that's actually something that I guess I've always been interested in pushing my limits, because I just want to see how far I can go before I actually can't do it all. Like how far can I go before I can't actually do a day job and try and run my own business and try and, you know, learn games programming on the side. But there's a bunch of other things outside of all of the stuff that I am giving a lot of time and attention to, outside of prioritizing family, right, that are that I don't focus on as much, right? Like I don't have gaming as much as a hobby at this point. I haven't made time for music in a long time, but I expect that will change at some point, especially when I get around to a point where I like want to make music for my game, right? I'll probably try and make it myself and see how far I can get with that before I become impatient and decide to start paying for music or something, or using royalty-free stuff. But I think realistically, I will probably try and make most of the sound effects and music as I can on my own. But we'll see. We're still so far from that point that I'm not thinking about it too much right now. Anyway, yeah, so I think we are okay to just go back to that procedure and hopefully finish implementing it so that we can wrap this up.
And we'll say that that's 16, so tiles per chunk equals 16, right? and we'll just leave that up here for now. That could be parameterized later if we wanted to, because we don't really use it in a lot of places. It's not a particularly interesting function. So we got our abs tile x, and our abs tile x is going to tell us where we were, and these are sort of signed now, right, as well, if I remember correctly. I don't know why they were still all unsigned in there, right, because we were sort of saying that our tiles now could roam positive and negative, right? They were starting at 0 and that sort of stuff.
Aha. So that goes back to what I was saying the other day when we made that change to go from unsigned to signed. And I had to make that change in a bunch more places, but he wasn't making it in as many places, and it's just because, you know, his compiler with C is not as strict about these things as Odin's compiler is.
But yeah, a lot of this code is still legacy from when we were first doing our initial testing. So what I want to do here is I want to just basically say, all right, whatever you passed me in, I need to figure out what chunk we would have been on, right? And so if the first chunk is at 0, 0, then if that was the center, I don't know exactly where we want center, but let's say that our chunks are centered at 0, 0. That seems reasonable to me relative to tiles. Then what we want to do is we want to basically, every time you go 9 tiles, right, you're going to when you move away from 0 a certain number of tiles, you're going to get into the next chunk. So what I want to do is I want to divide this by tiles per chunk. That tells me how many tiles I would have to go in that direction, but it depends, like I said, on how I want to center the world. I guess I could center it so that the bottom left corner of a chunk, yeah, all right, we'll just do it this way. So that's how many away we are. So basically it's this, right? That's it, to figure out what chunk we're in. And then what we have to do is figure out where we are relative to the chunk, right? And so in order to find out where we are relative to the chunk, we just need to then take, so that offset, and right now we're not handling the z properly. So this is, again, move to 3dz, which we kind of need to do at some point, because we don't really have a way to capture an offset in z yet still. So all right, so if we have these guys, then essentially we know that the abs tile x, right, whatever that number came out to be, and it could be negative, right? It could definitely be negative. We know that whatever the abs tile x was minus the result, whatever the result of the divide was, times the tiles per chunk. This is how many were left over, how many tiles we did not account for, right? Whoa. Okay, my keyboard has stopped allowing me to go upward. I'm not even joking right now. I cannot move the keyboard upward. Why is that happening? Like literally the up key has gone away. That would make it harder. Well, not that much harder. So anyway, if I wanted to, I can always just, oh, in my home key, what did I do? Did I hit some kind of a control state of the keyboard? Hold please. I do not know what just happened. I don't know that I want to know what just happened. Let me plug it, unplug it, and plug it back in again.
I'm just glad it's not me. I'm just glad this didn't happen to me.
Yeah, whew. All right, well, it's back. That's always good. All right, so just finishing up, the offset here is just going to be however many tiles there were times the tile side in meters, right? And I think that'll give me the offset x and y, right? I'm pretty sure that's all we really need there. So that way we have sort of that tile difference, like so. And then we just do the y. And again, we're waiting right there. We want to be able to compute the z offset as well, but we don't have that option at the moment, unfortunately. So I think that's it for that, and we are probably horribly broken right now, but I will go to the Q&A anyway, because, yeah, I'm assuming this won't run at all, and it doesn't, as you can see. So that's where we're going to leave our poor little hero for today, but just because, you know, what are you going to do? You can't. Sometimes you have to let the hero just sit for a little while. He has to kind of think about his situation, and then, you know, you come back to it later, and we're good to go. So, all right. So we've done that, and we'll leave everything for tomorrow, which is probably when we'll just finish this up, so it seems pretty good. We will go to the Q&A now, so please prefix your questions with Q:, and so that I can see them. And please keep in the stuff that we've done on today's stream or on previous streams. If you want to talk about other stuff, like how to get into the game industry, or what software to use for doing something, or if you just want to talk about random stuff, we do those kind of questions, but we do them before the stream. So please come about 15 minutes before our scheduled start time if you want to chat about stuff. We often do, and it's a lot of fun, so come for that, for sure. But for right now, let's just do questions on what we've been working on for the past days.
Okay, so the good news is that it sure looks like he has the same exact bug that I have wrapping today up, so that's nice. But I still have to do this calculation right, and honestly I think it's right, but I think we need to just do a cast, and we need to wrap that first set of operations in some parens, it looks like. Is this a float? It is. Okay, so that's good. We'll just do that then. And make sure that mine is just as broken as his. Unless, of course, we can't even compile. What's going on here? probably need to pass in the world as well. Yeah, that's what I thought. That is what I thought. And then somewhere else we're calling this. So right here we also need to pass in the world, and then mighty. Can you stop making those sounds over there? That's disgusting. What? Oh, world is undeclared, so I can just pass in the game state world and a reference to it. Right? Oh no, it's already a pointer. Is that right? Okay. Now, are we stuck, stranded in the middle of nowhere, unable to ever venture forth from this place? It sure looks like it. So we've regressed, but we've regressed just as much as Casey has, and that's fine. Unfortunately, I would love to, you know, sit and chew on the Q&A here for the next 20 minutes or so, but I'm past the point where I would have liked to have wrapped up the stream, but it's a silver lining for me, because we managed to pull it out in the end. You know, I deliberated a lot over, what was that, change, whoops, let's go in here. Change entity location. That was kind of painful, but I think I needed to do it. I needed to really appreciate what was going on here, because this was probably the most complex piece of code, at least as far as the entities and relating them to where they are in the world goes. Like, we're putting a lot of things together that it's a lot of steps to get to this place, and I just wanted to appreciate the benefit of what we were getting out of writing this code, and I'm still not even quite there. I still really want to make sure, you know, whether maybe we'll come back around and we'll actually handle this case like I was saying, where we don't actually, basically this case where we would potentially have a stale low entity index hanging around. I feel like that could totally be a thing, but we'll see if it comes up. If not tomorrow, then maybe just later sometime this week or far off in the future. I don't know. But I'll have to just be satisfied in knowing that we are in the same broken state as Casey heading into day whatever tomorrow is, day 58. What are we doing tomorrow? Let's just get a preview here. Using the spatial partition. So just continuing along this train of thought and continuing to flesh out this code to make use of that, because we're still not calling it. Right, that's the big thing here. We're still not using it, so tomorrow we'll use it, right? Which is exactly what the title is. So totally makes sense. Thanks for hanging out with me on stream and enduring this with me. It's definitely pretty technical stuff at times, but this is like really only scratching the surface, which kind of makes it scary, but also exciting at the same time. So. And by the way, Skinny Pepe, thanks for the follow, and Shazig, thank you for the follow about 45 minutes ago. And that's it. Have a good rest of your night, and I'll see you in the next one.